Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be adding complex numbers. Actually, we're going to be adding powers of 1 plus I, which you should hopefully recognize from previous videos because this is a special product. Okay, so I'll be presenting more than one method, hopefully two methods at least. And the first method kind of depends on looking at powers of 1 plus I. See if we can find a pattern. Can we find a pattern? You hopefully know that 1 plus I squared is 1 plus 2I plus I squared, but I squared is equal to -1, so we can go ahead and cancel these out and end up with 2I. That's what's special about this number, because when you square it, you get 2I. And there's a good reason behind it, because if you look at the argument of this, you're going to get pi over 4. And obviously, when you double it, you're going to get pi over 2, which is basically a positive multiple of I. Make sense? This is true for all these numbers with the same argument. But what about a pattern? What is 1 plus I to the third power, right? That should be 1 plus I squared multiplied by 1 plus I. But 1 plus I squared is 2I, so it's 2I times 1 plus I. And that should be 2I plus 2I squared. I squared is -1. This should give us -2 plus 2I. So that's 1 plus I cubed. And let's do the fourth power. See if we can find something interesting. Maybe we'll do a couple more powers. 1 plus I squared can give us the answer. This is 2I. 2I squared is 4I squared. I squared is -1, so this is going to be -4. Let's do fifth power. Maybe it'll give us a pattern, because so far I didn't get anything helpful, or at least I couldn't figure it out. 1 plus I to the fifth, I can just multiply 1 plus I to the fourth by 1 plus I, and then that's going to give me -4 times 1 plus I, and that'll be -4 minus 4I. Okay, cool. Let's go ahead and write these powers. Second power is 2I. Third power is -2 plus 2I. The fourth power is -4. Fifth power is -4 minus 4I. Do you see a pattern? I don't. But there might be one. You could try 1 plus I to the sixth power. Basically, every time you're going to multiply by 2I. And I think that multiplication by 2I is definitely going to give you something interesting. Because if you think about this one, let's do one more. You're going to get -8I. And then minus 8I squared, which is going to be a positive 8, minus 8I. Well, it's kind of like powers of 2, I should say. But it doesn't really look like a really nice pattern. But you can definitely try this and find the sum. It's not too many powers, only goes up to the 9th power, so you could get that. We're only on the 6th, right? So only a few left. Anyways, our focus is gonna be on the second method, I think. So let's go ahead and take a look, because second method should be cooler, right? Now we have 1 plus I to the second, 1 plus I to the third, all the way up to the 9th powers. Awesome. Now we're going to go ahead and use substitution. Let's go ahead and replace 1 plus I with z. That's a complex number, right? So this is going to be like z squared plus z cubed plus z to the fourth all the way up to z to the 9th power. What does that look like? Doesn't that look like a geometric sum or geometric series? Yes, it's a finite geometric series where the common ratio is z, or 1 plus I. Cool. Great. Then we can basically do the following. I can take out a z squared, factor it, and that gives me 1 plus z plus all the way up to z to the 7th power. And this expression can actually be written as a quotient. How do you do that? Because what we can do is we can take this, multiply by 1 minus z, and divide by 1 minus z. When we distribute 1 over this, we're going to get all the powers 0 to the power 0 through 0 to the 7th. And then when we multiply by -z, we're going to get all the powers of z through z to the 8th, but they're going to be negated. So all the powers are going to cancel out except for two terms, and those are going to be 1 minus z to the 8th, and that's going to give us the answer. In other words, from the geometric sum formula as well, we could say that this is equivalent to 1 minus z to the 8th divided by 1 minus z. Now, if you look at it differently, you can obviously set this equal to s like for sum, and then evaluate it that way too. That's the whole idea. But as a general formula, you can kind of look at it this way. If this goes up to r to the power n minus 1, by the way, this we end at r to the power n minus 1 because there should be n terms. So this is the nth term, right? Makes sense. And that's finite. This can be written as 1 minus r to the n divided by 1 minus r. When r is between -1 and 1, obviously, the infinite sum will converge. And this limit is going to approach 0. So we'll get the formula 1 over 1 minus r for the infinite case. But that's a different story. Don't worry about it. This is our formula. We used it and we got the answer. Awesome. How do we use that answer though, right? So here's how. We have 1 plus I squared plus 1 plus I cubed all the way up to the 9th power. And we realize that, hey, the sum can be written as z squared, which is 1 plus I squared, times 1 over 1 minus z to the 8th divided by 1 minus z. Make sense? That is what the formula gives us. So let's go ahead and evaluate it. This is going to be 1 plus I squared, which is 2i, and then 1 minus 1 plus I to the 8th. So we still have to evaluate the 8th power of 1 plus I, but that shouldn't be too hard because you know why? Because you're going to take this, square this, you're going to get -4. That's the 4th power, right? And if you square it again, you're going to get positive 16, which is the 8th power. So this is 1 minus 16. Make sense? Very easy. So even powers of 1 plus I are very nice. And then, or I shouldn't say even powers. Powers of 1 plus I, there are powers of 2. Okay, like 2, 4, 8, 16. Okay, yeah, that's kind of like a weird sentence. But anyways, 1 minus I, 1 cancels out. We end up with negative I. I cancels out, leaving us with a negative. This is a negative 15, so that makes it a positive 15. 2 times 15 equals 30 should be the answer. By the way, I didn't check my answer with Wolfram Alpha or any other tool. Please go ahead and check it out for me. Maybe I didn't make a mistake. Maybe I made a mistake and this is incorrect. And I'm pretty sure you're going to let me know. Anyways, this is pretty much it. Now, I'm thinking about this problem and could there be another way to approach it? Let's go ahead and quickly think about if there is any other alternatives. Well, when I expanded the powers of this number, I did not really get any patterns. Maybe I missed it. There's one, but I didn't really see anything. So if you do know of another way to approach this problem, please let me know. I'll be more than happy to know. Anyways, this brings us to the end of this video. Well, thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.